Morning, Aaron. Morning, Allison. All right, another few seconds, and we're just gonna get started. I don't like waiting too long. Behind this. Allison, can you like type in a yes if you can hear me and also see my paper right now? All right. All right. Well, I'm just gonna start. It's already 10:47ish. Maybe you guys already saw. So check this out. Just whoa, what the heck? To kind of make sure, right? What we're doing this week is like we have to start, Unit 3. Like we gotta, we don't want to like, I don't know. When this is all said and done, like there's certain things we gotta accomplish. So we might have to like pick up the pace a little bit. But what we're going to be doing is we're going to be like skipping technically the 3-1 notes. So 3-1 notes we're kind of skipping. We're going to be doing the 3-1 homework like together really quick here, but just the evens. And then we're also going to be like skipping, what is technically the 3-2 and 3-3 notes. And we're just going to do like some of the 3-3 classwork together. And that would kind of be like our notes. So we got to kind of start picking up the pace a little bit. So again, skipping some stuff. Hey Connor, hey Dakaya, and we're gonna go right to the 3-1 homework, and we're gonna do just the evens. And so when you turn this in, all I need is the evens that we're gonna do. So like Jesselyn. We're now doing equations. Like in chapter 2, we were just doing polynomials and we were multiplying stuff and we were factoring stuff, but they weren't actual equations. Now we're back into the world of equations, and I hope this is familiar to basically everybody. We're going to be just doing some like solving for x, and this right here on this 3.1 homework, this is like just some quick multi-step where you do a couple of steps to kind of solve for x. Jesselyn, do you know what the first step here would be to solve for x?
Add 3.
Awesome. Okay, just man. I know this might be catching a lot of you guys off guard. We're like, oh my gosh, we're all of a sudden out of nowhere we're back to solving for x. But yeah, good job. Remember, everybody, that the equal sign is what separates the left side from the right side. And what we have to do is add 3 to both sides. And that basically leaves 8x over here. The right side becomes 16. Jesselyn, do you know what the other thing to do here, the next thing to do?
Divide both sides by 8.
Yeah, very good. Because what you want to do is like the opposite. So Jesselyn added 3 because that was the opposite of subtracting 3, and that got that out of there. Now she wants to get the 8 out of there. And if it's 8 times x, the opposite is dividing by 8. So that leaves x all by itself, and the other side is 2. Moving on to number 4. Okay? Dakaya, what do we do here in number 4? Talk me through number 4 as we get x by itself. Remember, the equal sign is what separates. So Dakaya, what do we do here in number 4? Do you know?
No, I don't know.
No? Well, so x is what we want to get by itself. We want x to be the only thing on that left side. See all this other stuff on the left side? We have to like undo that. So the first thing we would undo is this plus 3. So the order matters of what we do. So I got to cancel out this plus 3. I got to like get rid of it. I got to undo it. And the opposite of adding 3 is subtracting 3. But whatever you do to the left side, to keep it balanced, you also have to do to the other side. So that's gone. So now I have 9x over on the left side, and the right side has become 9. 12 minus 3 is 9. Now I got to get rid of this 9, you know. So in order to cancel out the 9, this is 9 times x, and I want to leave x as the only thing left over on this side. I now divide both sides by 9. So that leaves x by itself, and then Dakaya, what's 9 divided by 9? Because on the right side, sorry, what? Yep, so there's the final answer. Moving on to number 6. Okay, Jack, talk me through number 6, getting x by itself.
Subtract 5 from both sides.
So that leaves x over 10 over there, because that cancels out, and the right side becomes 2. Now what?
I don't know.
Oh, come on, Jack. What does this say? This says x divided by 10, right? Technically. So if I want to get rid of this divided by 10, like what's the opposite of dividing by 10?
Multiplying by 10.
So that's what we do, people. A lot of people forget that. So that I'm really glad number 6. I mean, I kind of did this on purpose when I said we're going to do just the evens. Or, you know, when I was like, do we do the evens or the odds? I definitely wanted to make sure we did a problem like this, but then, you know, it would have happened in number 9. But anyway, the bottom line is I'm glad we did an example like this, because a lot of people forget about this. This, again, so to repeat that, this says x divided by 10. The opposite of that is multiplying by 10. So that cancels out over there, which leaves x all by itself. And again, whatever we do to the left side, we also got to do to the right side. So 2 times 10 is 20. And whenever you get x all by itself, that means you're done. And so the final answer here is 20. Okay, and then finally, number 8, just to kind of wrap this up. I don't know. Let's see if anyone else has jumped in here really quick. No, doesn't look like it. Connor, number 8, what do we do to solve for x?
Well, first we're going to add 2 to both sides.
And remember, people, a lot of people forget that it's the equal sign. Like, believe it or not, a lot of people I see will like, they'll add 2 to here, and then they'll also add 2 here, which is like, what? What are you doing? Like, you got to add 2 to both sides. So that leaves 4x over there, and then 32. Now what, Connor?
Divide by 4 on both sides.
Nice, and that leaves x alone, and over here that's going to be 8, I believe. All right, gang, so don't forget to turn this in as is, like as soon as this meeting's over, because this is an assignment of the 3-1 homework. But again, like, I'm trying to fast track this. You know, like, we're gonna be doing this kind of stuff anyway as we build into like 3-2 and 3-3. So don't forget to turn this in when we're done here. But let's now move on to, and again, we're skipping stuff, but we're moving on to like the 3-3 classwork. So this paper's probably right after your 3-2 and 3-3 notes, which is kind of blank actually. Like, they're almost blank pieces of paper. But we're gonna skip those notes, and we're gonna basically do this as our notes. Okay. So now this is the same thing, right? Like, you know, elephant in the room, right? It's the same thing, except we're getting a little more complicated. Now we can deal with like variables on both sides. I mean, look at this. Okay, Aaron, do you know what the first thing we would do here in number 1? So how would we handle the fact that there's an x and an x now on both sides. What do we do, Aaron? Do you know?
Subtract 3x.
Yeah. The first thing we probably want to do is, move the x's to only one side. Now, what a lot of people like to do is always move the smaller one, Like here, the 3x is the smaller one, so we kind of like move that. So how do we get rid of the 3x from that right side? We subtract it, so that now that's gone. And so over here, Aaron, what's 4x minus 3x?
X.
Yeah. If Aaron would have said 1x, she also wouldn't have been wrong, but I like when people cut to the chase like that, like 1x is really just x. Now, everyone, okay, everything else just drops down. The 3x is no longer there anymore, so now we just have that positive 5. All right, now what's the last thing we do, Aaron?
Add 2.
Yeah. See, now that we only have x on one side, now we got to get it all by itself. So like we're back to what we were doing, over here in section 3.1. So that cancels out, and so x is all by itself, and the final answer is x equals 7. Now compare that. Let's jump over here to number 4, actually. Okay. Jesselyn. You see how there's a negative 2x over here and a 5x on the other side? Do you have something that you would think to do first? Like, what would you do first, Jesselyn, like, as far as the x's?
I would subtract 1.
You would subtract, like...
5 and minus 2.
All right. Well, here's the thing. When these x's are not on the same side, don't combine them, If they're not on the same side yet, the first thing we have to do is get them on the same side. So here's my choices. I can subtract 5x away from the right side. You know what I mean? I can subtract 5x from both sides, which will now they'll no longer be this on the right side, and it'll only be on the left. Or what you can do is add 2x to both sides, because again, before these x's can combine, you have to kind of get them on the same side of the equal sign. Now, what I was saying earlier was most people like to always move the smaller one. So that would be the negative 2x. Negative 2x is smaller. So I think what a lot of teachers will kind of say to do is that. Okay? And the reason that's a good thing is because when you do 5x plus 2x, it's going to be positive. You're not going to be dealing with any negatives. Likewise, see, compare that with this. If I would have said, I want to get my x's on the left side all the time. That's what I find important. I want to always get my x's on the left. Well, if you're that type of person, you would have been subtracting 5x from both sides, and you would have ended up with a negative 7x over here, a negative 7x over here, which is not, that doesn't mean you're wrong. It's just you'll get the same answer at the end of it all. But anyway, I hope I'm making some kind of sense where I think a lot of people would rather end up with a positive 7x over here than a negative 7x over here. But anyway, everything else drops down. The positive 3, this minus 4. So now that's where we're at. All right, Dakaya, now that we have this, now we got to get x all by itself. Now that we only have x on one side, now what do we do, Dakaya, to get x all by itself? Do you know? we got to get rid of the 7 and this minus 4. Which one do you think we want to get rid of first? Actually, no. What you want to do is you want to, like, kind of work on, like, get rid of this completely separate term first. So what we want to do is, like, add 4 to both sides to get that out of there. So on the left side we'll have a 7, and on the right side we'll have a 7x. Now we divide by 7. So the final answer is 1 equals x, or, x equals 1. So whenever you're in a situation like this, it's kind of like, back here in 3-1, where we want, like right here, we wanted to get x by itself, but you got to add or subtract before you multiply or divide. Like, that's important to do in that order. Okay? Like number 2, the first thing I would do is subtract 6x from both sides. Okay? And that means over on the left there'll be a 2x minus 3, and on the right side now there's only going to be a 7. So again, now it's like, okay, what do we do? Do I get rid of this minus 3, or do I get rid of this 2? You definitely need to do the opposite of that first. So add 3 to the other side. And now your equation says 2x equals 10. Now we divide by 2 to get rid of that, because this is like 2 times x. So we do the opposite, right, to get rid of it. And we get a final answer of x equals 5. Okay? Really quick, gang, think to yourself, what would you do first in number 3? What would you do first in number 3? Perhaps what you thought to do was subtract 2x from both sides. So that's now gone. Now this is a 3x with the minus 4, and over here we have a 14. Then what would you do? You should probably add 4 to both sides, because now we got to get that x all by itself on the left side of the equal sign. So now we have 3x equals 18, and now we can divide both sides by 3. And so x equals 6. All right, Jack, what would you do first in number 5?
I would add 3x to both sides.
Me too. And if some of you were thinking, let's add x over here to the left side, you wouldn't be wrong. You could have also done that. But this way, Jack is saying that negative x plus 3x is positive 2x. See, now we're not going to have any like negatives with our x. So we still have a positive 8 over there, and this minus 2 comes down. And then now you're just, right, getting x by itself. So Aaron, what's the next thing we do?
Add 2.
Add 2 to both sides. Because again, whatever you do to one side, you got to do the other side. And then now you have a 2x by itself, but I want x by itself. That 2 has got to go. And the way we get rid of that 2 is by division, because that says 2 times x, and the opposite of times is divide. And so we get x equals 5. All right, Connor, number 6. What's the first thing you want to do in number 6, Connor?
First, you want to move the x, so I always move the one that's on the right.
Hey,
That's just personal preference.
yeah, you know what? Actually, I kind of lied earlier. That's usually my preference also. But so you want that negative 6x to not be on that side.
Yeah.
So we want to do what?
Add it to the other side.
Yep. And actually, it turns out that no matter what type of person you are, if you like moving the smaller of them so you keep it positive, that you would have done the same move, adding 6x to both sides. So now that's gone. And then, so what's your new equation now, Connor?
2x plus 7 equals -1.
Good. So that's a -1 that drops down. And then now what do we do, Dakaya? Now that x is only on one side, now we want to get it all by itself. So what do we do next to get x by itself? That wouldn't be wrong or anything. Like we can move this 2x to the other side. I mean, that wouldn't be wrong, necessarily. But I don't know if that's going to see, once we get the x's only on one side, now we get rid of the other stuff that's crowding around it, because at the end of the day, we want x all by itself on the one side. So we don't need to move the entire 2x anywhere. And actually, we don't even want to attack that 2 yet. We want to get rid of that +7. We want that +7 out of here. So, Dakaya, how do we get rid of that +7? No, we got to do the opposite. So the opposite of adding 7 is subtracting. See, that's what's going to... We literally have to cancel it out by doing the opposite. So we subtract 7 from both sides. So this +7's gone. And on the left side now, you see how x is now a little bit closer to being all by itself? And on the right side, -1 minus 7, that becomes a -8. Okay? Now we get rid of this 2. So Dakaya, how do we get rid of the 2? This says 2 times x. So what's the opposite of times 2? So we divide both sides by 2. So because that's going to get x all by itself on the left, and then on the right it looks like we're going to end up with a -4. So that's that final answer. Okay? So then there's a back. All right, so check this out. And if someone's... I don't know if Connor is still unmuted or whatever. Nope, we're good. Who did we lose here? Keep losing Jesselyn. But anyway, so check this out, Dakaya. You see how there's... Whoop, too high. You see how we have a couple of x's over here? They're already on the same side, So this is one of the first things you do. If you see terms that are like terms that are already on the same side as each other, you can just combine them. So the very first thing I would do here in number 7 is just combine those together, because they're like terms and they're already on the same side as each other. So this -20 drops down, and -4x minus 6x is -10x. You see? That's a different story than number 9. In number 9, this 8x and this 7x are on different sides. So you wouldn't just combine them. You would first have to get them on the same side by doing that. Subtracting 7x away from the right side over onto the left side. You know what I mean? So it's a different thing. So now that I'm here in number 7, now I just want to, see, I only have x over here on the right. Now I want to get it all by itself. So this says negative 10 times x. So I divide both sides by negative 10 to get x all by itself, and then negative 20 divided by negative 10 is positive 2. And then once you get x by itself, you're done. In number 8, Jack, what's the first thing you would do in number 8?
You would combine 1 and 5.
Yeah, you know. Is there other things you could do that could end up making, having a, yeah, but, I mean, that's what I would do. If you already see two like terms that are already on the same side, you can just combine them, and I think you should just combine them. So we have a positive 1 and a positive 5. So that 6 drops down. The 1 and then the positive 5, they make 6. And then that minus 2n drops down. All right, Jack, what would be next?
You would subtract 6 from both sides.
Very good. This isn't very good. A lot of people would forget that this is a positive 6. Hey, people, this minus sign goes with the 2n, not the 6. That 6 is a positive 6. The way we get rid of it is by subtracting. So we subtract 6 from both sides. That's gone. Well, actually, guess what? Over here, that's also gone. So what does that mean? What's 6 minus 6 over here on the left? Like, we kind of have to write a 0, don't we? Technically, this is a 0, but we don't have to write it because we have a minus 2n over here. But over here, like, we literally have to write 0. And then we would now divide both sides by negative 2, right? Because, again, we want to leave the n over here by itself. So we only divide both sides by negative 2. And that leaves the n, like as a survivor, basically. And then 0 divided by negative 2 is 0. In number 9, we already started it. We had to, subtract 7x from both sides. 8x minus 7x is just x. The minus 2 drops down. Over here, the minus 9 drops down. And all we got to do here is add 2 to cancel out that minus 2 so that x can be by itself. Negative 9 plus 2 is negative 7. Don't believe me? Go to your calculator. All right. Allison, for number 10, I think you can type this. What's the first thing we would do to both sides in number 10, Allison? What would you do to both sides to start number 10? Well, we have this negative 5a on the right side. We have this 1a on the left side. We can't just combine them. We have to get them on the same side first. So, usually, if you're well, here's something you can do. You can add 5a to both sides. That's going to cancel it out on the right, and now it'll be over on the left. And we can do a plus 5a. That's 6a. Then the plus 5 drops down. This positive 5 drops down. And so now we've gotten the a's only on one side. So now it's time to get a all by itself. So Dakaya, coming back to you. What's the next thing we do so that we can get a all by itself? Very good. We want to subtract and get that out of there. Of course, we got to do it to both sides. So 6a is now the only thing on the left side. 5 minus 5, again, we literally got to write 0. That's okay. Then what do we do, Dakaya? To finish getting a by itself.
Divide 6.
That's right. So now a is by itself, and then 0 divided by 6, well, that's still 0. So, hey, just like in number 8, you can get an answer of 0. That's allowed. That happens. That's a thing. So just like in number 8, our final answer was 0. Aaron, what's the first thing you want to do in number 11?
Subtract 5.
Subtract 5p, technically, right? Don't just subtract 5. Subtract 5p. And if you were Connor, you probably are doing something a little different, which is fine. But if you want to keep things as positive as possible, then yeah, like you subtract 5p. So we still have a negative 14 over there on that side, right? 8p minus 5p is 3p. The plus 4 drops down. What's next, Aaron?
Subtract 4.
Very good, which that gets that out of there. So now you only have a 3p over there, and it's getting closer to p being all by itself. Negative 14 minus 4. Remember, go to your calculator if you have to. But that should be negative 18. Then we divide both sides by 3. And we get negative 6 over here, and p's by itself over there. Ooh, number 12. This is going to get a little interesting. Connor, what would you do to both sides first? Or what would you do first overall? What do you think, Connor?
I don't know.
Well, you might be thinking too far ahead. Just like we have a p over here, which is technically 1p. We have a 1p on the left side. So, like, I guess, there's no like terms. And listen, everyone, let me interject something really quick while we're talking about number 12. On your eventual homework, okay, like this is your eventual homework. That's also posted today. When you look at like a number like 12, there's like a hierarchy of priorities you would do, When there's a bubble, okay, this takes a very high priority. So if I were to ask you, what's the first thing we want to do in number 12? You should say, we want to distribute. Clearing bubbles is a very high priority. Okay? So in number 12, the first thing you'd want to do is distribute the negative 5 to clear the bubble. So you would have like a negative 30n minus 30, and then you would continue. But clearing bubbles, clearing parentheses with the distributive property is a very high priority. Just like in number 9, where maybe the next highest priority would be combine any like terms that are already on the same side. Like number 8, these are already on the same side, right? In number 9, they're already on the same side. So that's like the next priority, So Connor, looking at this number 12, there's no bubbles to clear, otherwise that we would want to do that probably first. There's no like terms on the left side. There's no like terms on the right side that we could, otherwise we would do that. But we do have p's on both sides, and we got to fix that. So what do you think, Connor? Does that help? Like, we got to get the p's only on one side. So what is that move going to be to do that?
Subtract p, but like...
Yeah, no. Look, don't think too far ahead, okay? Subtracting, which is technically like minus p, right? Minus 1p, yeah? So that's gone. But I think what is, tickling Connor's brain right now is that, oh my gosh, look at the left side. This isn't like 5p minus p or negative 2p minus p. This is also gone. So our variable totally canceled out. And what was left over is -4 equals -9. It's technically 0p over here, but really, -4 equals -9, which is false. Do we know what that means? When the variable totally drops out, completely disappears on both sides, okay? And we have like no more variable at all. And what you're left with is a false statement. What that means is no solution. So plot twist, we're also throwing these into the mix, where you could have like no solution, okay? When the variable totally drops out and you're left with a false statement, no solution. If this had said like -9 equals -9, or 7 equals 7, or 0 equals 0, that would have been true, and your final answer would have been infinitely many solutions. Or you could have said something like, it's always true, right? Let's see if that happens in the homework really quick. In the homework, I did notice something. So here, gang, on your eventual homework, it looks like that happens at least one time with number 7. Check out number 7 on our homework. -14v plus 14v. That's already on the same side. So that's gone. Those just combine to be 0. So we have, there's no v's left. It's like 0. And so we have -10 equals 0, which is false. So once again, the final answer here is no solution to like homework number 7. Okay, so just be ready for that. It shouldn't happen that much. It shouldn't happen that much, but it can happen. You know what I mean? And once again, if what your statement would have been is like actually true, like -10 equals -10, or 0 equals 0, then the final answer would have been like infinitely many answers, and it just were like always true, okay? But anyway, that's basically it.